Okay, as we finish up the section 2 or section 23 assignment, we're asked if these are directly or inversely proportional. Oh, I won't write over there, but so if it's directly proportional, it ought to follow W equals K times S. And if it's inversely proportional, it ought to follow W equals K divided by S. So, and it ought to follow that pattern every single time. So if it's it ought to follow one of those two. So K in this situation, in the directly proportional versus inversely, K would be equal to W divided by S every single time. And in this, in inversely proportional, K would be equal to W times S. And times S on both sides, we get K by itself. Divided by S on both sides, we get K by itself. So it ought to follow this pattern or this pattern every single time. So we will test out whether 2 divided by 5 is equal to 4 divided by 10 and 6 over 15 and 8 over 20 and 10 over 25 every single time. And if it is, then it's directly proportional. And if you look at those, or if you put those in your calculator, those will always reduce to 2 over 5. So that means that 15 is directly proportional. For number 16, if you try to see if it's directly proportional, again, is negative 3.5 over 5 equal to negative 7 over 10 and negative 10.5 over 15 and negative 14 over 20 and negative 17.5 over 25. It should always be consistent that way if it matches up with directly proportional. If it's not, then we'll test the inversely proportional situation. But all of these do reduce down to, you put those in, any of them in the calculator, you get negative 0.7 every single time. Which means that 16 is also directly proportional. On 17, you can try the same thing. Remember, if it's directly proportional, it'll be W. You'll have a constant number when you divide W by S, or that's for directly proportional. And for inversely proportional, you'll get a constant every time you multiply W times S. So, calculator, try W divided by S and see if you get the same number every single time. So on the first one, 0.92 divided by 6.9, I get 1.33 repeating. Try the second one, 0.25 divided by 24.3, I get 0.010. And those aren't even close, and so I'm going to say it's not directly proportional. So we're going to try inversely proportional. That means we need to multiply W times S and see what we get every single, if we get the same thing every single time. 6.9 times 0.92, you get 6.348. 24.3 times 0.25, I get 6.075. Not exactly the same. Why it's doing this. So the second one I get 6.075, which is close. Both of them round to 6. So let's try the third one. 27 times 0.21. I get 0.5 or 5.76, which still rounds to 6, so I'm still close. Let's keep trying. 55.8 times 0.11. I get 6.138. Still rounds to 6. 107.9 times 0.056. 6.042. Still rounds to 6. 207.2 times 0.031. 6.4232. Still rounds to 6. And then last, 200.6 times 0.033. I get 6.6198. And so it's, all of them are close to being 6. So it would vaguely follow inversely proportional. With some margin for error. Same thing with 18. We'll try directly, and then we'll try inversely. So we'll divide first W by S and see if we get the same thing every time. 6.9 divided by 1, 6.9. 6.2 divided by 1.2, I get 5.166. Doesn't look good. And then 1.4 divided by, or sorry, 4.3 divided by 1.4. I get 3 point something. So I'm thinking it's not directly proportional. I'm getting farther and farther away from being consistent. So let's try to see if they're inversely proportional. 6.9 times 1 is, of course, 6.9. 6.2 times 1.2 is 7.44. 4.3 times 1.4, 6.02. 1.6 times 4.1, 6.56. 1.8 times 3.9, 7.02. 2.0 times 3.2, 6.4. 2.2 times 2.9, 6.38. And 2.4 times 2.8, 6.72. So all of these are between 6 and 7 when you round. And so that would be, again, it would be inversely proportional. At least it's more closely related to being inversely proportional than directly proportional. As we start section 24, we need to create a scatter plot for this data first. We put it here. Well, first let's put it on the calculator. So first thing we do is clear all prior do a fresh start. Second plus 712. Then we'll go to Stat, Edit, and we'll put our information in. We got years from 2001 through 2009. And I'll go back and put the matching numbers. 2000 is 21, and then 20.7, 21, 20.7, then 20 and 19.2, 20, 19.2, and 18.5 and 18.1. 17.8, 17.4, .3 and 17.9. Okay, then if I'm going to graph it, I want my window to be set at my smallest X value, which would be 2000, and my biggest X value would be the max, 2009, 2000, 2009. My Y values range from a minimum of 17.4 up to the biggest of 21. So I'm going to go 17 to 22. Seventeen's the room there, 22 there. When I graph, nothing shows up because I need to turn my plots on. So go to second Y equals. Make sure the on is highlighted. And when I hit graph, there are my points. Okay, so your graph ought to look something like that, with the numbers 2000 to 2009 along the bottom, and 17 to 22 along the left side. Then display the median line on the scatter plot and find its equation. So to get the median line, go to Stat, over to Calc, number 3. You will just press enter. So I get Y equals negative 0.4x plus, we'll call it 821. Negative 0.4x plus 821. We'll put that in Y equals negative 0.4x plus what was it? 821. Graph, and that's where you should draw your median line. What is the meaning of the slope in this line? Well, the slope is the decrease in the number of females who smoke, the decrease in the percent of females who smoke over the course of the number of years. So the percent of females who smoke has been decreasing since 2000 to 2009 at a rate of 0.4% per year, or 40% per year. Oh, 0.4% per year. So, next thing is display the least squares regression line on the scatter plot and find its equation. So to get the least squares regression line, go back to the home screen, do stat, over to calc, number 4, linear regression, press enter, and we get a negative 0.37, so again a negative 0.4, or you could call it negative 0.38 x plus 775 or 776, so I'm going to go negative 0.38 plus 776. Put that in y equals, in y2, negative 0.38 x plus 776. See how those two lines compare. Okay, very, very close. I don't even see the other one. I don't think it's, let me see, zoom out. Let's see if it's there. Here's the first one. Oh, it's way down. So rounding is going to cause that one to be messed up. Maybe if I round better. Let's look at it one more time. Stat, calc, 4. Negative 0.38x plus 776. Okay. All right. So the largest residual for each of the linear models, if we turn the diagnostics on, if we go to second 0 for catalog, and go down to diagnostics. Should have done this before we did it the first time around. We wouldn't have to go back and do it twice. Find diagnostics. Turn diagnostics on, press enter, make sure it's done. Then we go stat, calc, 3, and didn't even give us an R value. Let's see if it does for linear regression. Okay, we have an R value of 0.89. So I'm guessing that the other one was probably better, since it goes through the middle of the points better. So the largest residual will be the one that's better. Which model do you think would be more effective in successfully predicting the year that the percent of female smokers will first reach 15%? Find that year and give a reason. Well, since the median line looked better, let's use it and figure out when it's going to be 15%. So if we go to y equals, and y1 was the one we liked. Arrow down until 15. 15%. Wait, we need to go to 2000. So in the year 2000, it's at 21%, and it starts to decrease, and it hits 15% at 2015. So the answer to F should be 2015. All right, let's go to the Super Bowl problem. Again, we need to put all of that information in our calculator and make the scatter plot. I'm going to clear everything out. Actually, I'm going to do a reset again. 2nd plus 7, 1, 2. I'll go to Stat Edit. And I need to put the years, and it's separated. Year cost, it's just a continuation. So we need to put the years from 2000 to 2013, and then we need to put the matching costs in each one. You're just going to 13. Okay. So we'll go back to the number of the cost of Super Bowl tickets, no, Super Bowl advertisements in thousands of dollars. So $2,100,000 means $2,100,000. So 2,100 and then 1,900, 2,100, 1,900, 2050, 2,100 again. $2,250, 2,400, $2,500, 2,600, $2,700, 3,000. It's kind of interesting why in 2010 it dropped back down to 2,650. Makes you want to go look up what happened in 2010. Maybe nobody cared about who was playing in the Super Bowl that year. 2011 was 3,000 and then 3,500. And then 2013 was 3,900. create the scatter plot and the median line and the least squares regression line. I'm going to go ahead and turn diagnostics on. Is. Okay, I'm going to go to stat. Well, before I do, let's set up the window. So my X values will need to go from 2000 to 2013. My Y values, well, let's do that first. Do my table. That's not a window. 2000, 2013. Y values, the smallest one I have is 1900. The biggest one I have is 3900. So let's go from 1800 to 4000. 1800 as my smallest amount of money. 4000 is just bigger than the biggest amount of money. Remember to turn my plot one on. Then go to graph, and there it is. Okay. So you plot that on your paper. Make sure you label the axis 2000, 2013, 1800 to 4000 on your y-axis. And then let's get a median line equation. You get y equals 100x minus 1000 or 198100. 198,100. 100x minus 198,100. 100x minus 198. What was it? One zero zero. Graph that. Draw that line on your graph paper. And let's do the linear regression line, number 4. Get 127.8. as our slope, and negative 253,817 as our y-intercept. I wrote it down this time, but I didn't do the residual. All right, 127 x.8 x minus 253,817. 253,817. Graph. Okay, both of those are pretty close. Now this one had an R value of 0.93, which was better than the one before. You just need to decide which one of those you think you like better. median, or the linear regression line. I'm going to go with the linear regression line this time, just because it kind of fits the data of what has been occurring most recently. It's a little bit steeper. So that's in Y2. Which model do you think would be more effective in successfully predicting the cost of Super Bowl in 2017? A Super Bowl ad. So in 2017, we would need to go to start the window at 2017. We go to the table. Then in 2017, Y2 is the linear regression line, and it predicts that it will be 3,000, well, that's actually $3,955,600. So this is what you would write down: $3,955,600. That would be your answer to the Super Bowl ad in 2017. Now, successfully predicting the first year that the cost of the Super Bowl ad will be at least $5 million. When will it be $5 million? If we use that same one, then $5 million will happen in 2026, according to the linear regression line, and it'll happen in 2031 if we use the median line. So you can choose and just make a reason for your description or for your prediction. Do you think a linear model is reasonable for this scenario? Why or why not? So we go back to graph. If we take those out from y equals, we look at the graph again. Does it look linear? I'd say it looks fairly linear. I don't see too much of a curve. Do you think a linear model is reasonable? I'd probably say yes. A linear model would be reasonable. Okay, let's go to section 25. We need to graph this function on the grid provided. So we're going to graph this. We want to look at where it's going to change. And it's going to change at 1. So right here is where it's going to change. Before, or for x is less than 1, it's going to be negative x plus 4. For x is greater than or equal to 1, it's going to be 3x plus 2. So let's start out with the less than 1, negative x plus 4. It's going to have a 4y intercept, 4, and it's going to have a negative slope, a negative 1 slope. So it's going to do something like this until it gets to that point where the wall is at. Then from there on, it's going to be 3x plus 2. So a 3 slope of plus 2, it would hit right here if it was long enough. Right here at plus 2. And then the slope would be a 3 slope. So you go up 3 and over 1. Be right here. Up 3 and over 1 again would be right here. And it only is going to start, though, at this point. It's going to have a slope that looks like a positive 3. So that's what your graph would look like. Now we want to go the other way around on this one. So we're going to write this in function notation, or it looks like it's in y in equation notation. So y equals, and then the wall is going to be created at two. So we have the point 2, 1, we also have the point 0, 3, which is right here. We have the point 3, 7, right here. And we have the point 2, 1, 2, 3, 4, 5. So that's going to help us find the equations of these lines. So since this is a closed circle, then we're looking at x values that are less than or equal to 2 is going to have the equation, the slope of this line is down 2 over 2. So 2 over 2 is a 1 slope. So it's going to be 1x, or just x. And then it hits at 3, so x plus 3. The other line, 2, 5 to 3, 7, means it's going to go up 1, 2, and over 1. So it's going to have a 2 slope. Oh, I need to fix on this one's going downhill, so that's a negative x plus 3. This is going uphill, so it's going to be a positive 2 over 1, or 2 slope. And then we need to figure out what the y-intercept would be, and this is not going to be too hard since it's kind of in the screen. If we go down 2 over 1, will be here. If we go down 2 over 1 again, will be right here at 0, 1. So 2x plus 1 would be the equation, but this is only going to occur when x is greater than 2. For number 3, we have 2 breaks. We have 3 pieces. We're going to have one equation when x is less than and equal to, this is at negative 1, and this is at positive 1. So less than or equal to 1. We're going to have another equation when x is between negative 1 and positive 1. And then we're going to have another equation when x is greater than or equal to 1. This should be a negative 1. So for the first part, this line has a 1 slope of 1 over 1. We got negative 2, 0, negative 3, negative 1, negative 4, negative 2. So that goes up 1 over 1 every time. So it's going to be a y equals 1x, or just x. And then if that kept going, it would hit right here at 2. So we x plus 2. 2 would be its y-intercept. The second piece is a horizontal line, so it's going to have a 0 slope, and it also hits at 2. So it would be 0x plus 2, or just y equals 2. And then the third piece is a negative 1 slope, so it would be a negative x. And if this kept going, it would hit at, it's at 2, 1, then it's at 1, 2, and then it's at 0, 3. So it's x plus 3 with a negative slope. For this piece, this point right here is the point 1, 1. And it looks like this point is about 0, 3. And then we have the point 3, 7. So the equation for this step function is going to be, it's going to have one formula when x is less than or equal to 1. And it's going to have another formula when x is greater than 1. When x is less than or equal to 1, this slope is a down 2 over 1. So that should be a negative 2 slope. And it hits at 3, so negative 2x plus 3. It's the y-axis at 3. This line has a, let's see, that's 1, 1, and we would go down 6 over 2. That would 6 over 2 reduces to 3, so that would be a 3 slope, 3x. And then if it kept going, down 3 and over 1, 1, 2, 3 over 1, we'd be at negative 2. So 3x minus 2 would be the equation of the second part. And this function is all going to be horizontal lines. So y equals one thing when x is less than or equal to -2. It's going to be something else between -2 and 3. And then it's going to be something else when x is greater than or equal to 3. It's going to be a constant function. So before -2, or to the left of -2, this piece is going to have a 0 slope, -1 y-intercept, so just 0x minus 1, or just -1. In the middle, it's just going to be y equals 2, and over here, it's just going to be y equals 3. For this part, we have one speed, he's going to have one speed up to 15 minutes, and then another speed after that. So the equation of this part of the line is y equals, 0 to 6. So you're up 6 and over 15. Even though you can't count the squares here, it's a 6 over 15 when you do the rise over run. So 6 over 15 reduces to 3 to 2 over 5. Divide them both by 3, 2/5 x, and then it goes through 0, 0 for x values less than or equal to 15. And then after that, we have another point out here that's at 45, 9. And so this line right here would have a slope of 6, 7, 8, 9. So we went up 3, and we went from 15 to 45. So we went up 3 and over 30. 3 over 30 is 1/10. And this would have a y-intercept of, it's going down 1 over 10, down 1 over 10, down 1 over 10, down 1 over 10, would put it right in the middle. So that's 2, 3, 4.5 plus 4.5 for x values greater than 15. So find Kevin's speed in kilometers per minute for part of the trip from town A to town B. So from town A to town B, he rode to town A on a bicycle, and then he walked from town A to town B. So he was here at his house, and then he rode a bike. So he went a little faster. His speed was 2/5. 2/5 is how fast? Let's see. That's 2/5 of a kilometer per minute. Basically, he went 6 kilometers in 15 minutes. So we went 6 kilometers in 15 minutes, and we need his speed per hour. His speed per minute. We'll get to speed per hour in a minute. 2/5 is the same as 2/5 of a kilometer per minute. So he basically went 6 kilometers in 15 minutes. So you just say 2/5 of a kilometer per minute. I guess that's the same thing as 2/5 is the same as 4/10, so you can say 0.4 kilometers per minute would be the same thing. But that was for going on the bike. The second part would be from 15 to 50 minutes, and in that area he went 1/10 of a kilometer per minute. Or 0.1. So this is actually the answer to part B. And then 15 minutes after he left his house, Kevin's wife left on a bicycle at a speed of 42 kilometers per hour to try to catch Kevin on his way from town B, on his way to town B from town A. When will she catch up with him? How far away will they be? So, already saw this mess. Let's look at what Kevin's wife would be doing. 42 kilometers per hour is the same as 42 kilometers in 60 minutes. So if she stayed at that speed, then in 60 minutes, well, 60 is off the page, so if we reduce this, that would be 21 kilometers, everything will stay proportional, in 30 minutes. So 21 and 30, 21 kilometers would be way off our screen, so let's go down a little bit lower. Instead of 21, let's go down to 7. If we divide them both by 3, she would go 7 kilometers in 10 minutes. All of these are proportional. So 10 minutes, 7 kilometers would be right here. But she didn't leave until after 15 minutes after he left his house. So 15 minutes later, her distance from home is still here. And she's going to go in the next 10 minutes, so by 25, she's going to be at 7 kilometers. So that right there is the point. That's her speed, and that's the point at which they will meet. The time would be at 25, and the distance from the house would be 7 kilometers. In this problem, whose car had the largest gas tank? Well, who started with the most gas? That would be Jerry. Whose car ran out of gas first? Well, whose volume went to 0 first? That would be Alicia. Whose car traveled the greatest distance? Well, who was driving the longest? That would be Marissa. She was still driving. They were all going the same speed. So if she was still driving while the others weren't, she would go the greatest distance. Whose car gets the worst gas mileage? Well, whose line is the steepest? That would be Jerry. He had the largest gas tank, but he also had the worst gas mileage. Jerry's graph intersects Maria's graph. Jerry's graph intersects Maria's graph right here. What does that point of intersection represent? It means that's the time when they had the same amount of gas. So if we picture what's happening here, everybody's leaving the same spot. They're driving the same speed, so they are side by side, and then Alicia runs out of gas, and then Jerry runs out of gas and stops, and then Calvin runs out of gas, and Marissa keeps going. After some automotive work, Jerry is now getting better gas mileage, okay? So how is this going to affect his graph? Well, if he's getting better gas mileage, he's not going to run out as soon. So his graph might be able to do something like that. So how will this change affect his graph? Well, the line will